Have you ever looked at a massive factory with all its complex machinery and wondered how they keep a disaster from happening? Well, it's not just luck, it's a plan. Today, we're going to crack open a real-world safety document to see how these invisible systems work and, how they keep us all safe. Let's get into it.
It's a question we probably don't think about much, but it's so important. How does an ordinary food processing plant, a place making stuff that ends up in your fridge, manage the risk of a truly extraordinary disaster? Well, the answer isn't just crossing your fingers and hoping for the best. It's a highly structured, very deliberate process.
And to really get how that process works, we have to start by understanding the risk. Because hidden inside a lot of these everyday facilities is a potentially dangerous ingredient. So, at this Land O'Lakes facility, the secret to their massive refrigeration system is a chemical called anhydrous ammonia. It's absolutely fantastic at keeping things cold, but it's also highly hazardous if it ever gets out. This is the kind of stuff that demands respect and a really, really good plan.
And believe me, the stakes could not be higher. What's so interesting here is how the official plan itself defines the outcomes. A minor release is already pretty serious. We're talking possible injury, a contained problem. But a catastrophic release? That's a whole other ballgame. Multiple life-threatening injuries with an impact that goes way beyond the factory walls and out into the community.
So how in the world do you manage that level of risk? Well, you basically turn worrying into a science. You develop a formal process, a kind of systematic worrying, to figure out the worst-case scenarios and stop them before they ever happen. And that process is called a process hazard analysis, or a PHA for short. As you can see from the official definition, this is not just some simple safety checklist. It's a deep, methodical dive into everything that could possibly go wrong. The main thing to get here is that this is a formal, recognized discipline. Yeah, this whole process is the exact opposite of guesswork. It is a structured, collaborative effort. This is not about one person just walking around with a clipboard. To do this right, you have to bring together a whole team of experts. And this right here shows you exactly who you need in the room. You've got your leader, of course, but the real magic happens when you bring all their different areas of expertise together. The operations expert, they know how the system actually works, day in and day out. The maintenance expert knows what tends to break and why. And the engineer knows the original design, inside and out. Each one brings a unique and totally vital perspective to the table. So, you've got the team together. What do they actually do? Well, they get into a room and they start asking some incredibly important questions. Let's go inside the what if. Their main tool is a technique called the what if methodology. Now, it might sound simple, but it's a super powerful way to systematically explore every potential failure you can think of. It's all about imagining all the ways things could go wrong, one specific scenario at a time. Okay, let's actually walk through an example, one pulled right from the report. It starts with a simple question about a really common component. What if a ceiling component fails? This could be a gasket, an O-ring, something small but totally critical. So, step 1. They nail down the specific scenario. No gray areas. A ceiling component fails, and because of that, a leak develops. A clear cause and a clear effect. Step 2 is figuring out the consequence. Based on the details of this particular failure, the team figures it would likely result in a minor ammonia release. Now that's still serious, but it's not that catastrophic scenario we talked about earlier. Next, and this part is absolutely key, the team lists all the existing safeguards. So what systems are already in place to either prevent this from happening or to lessen the impact if it does? In this case, you can see there are a bunch of automated cutoffs and control systems designed to shut everything down before a small problem becomes a big one. And all that leads to the final conclusion for this specific item. After looking at the scenario, the consequences, and all those layers of protection, the team makes a judgment call. And in this case, team feels current safeguards in place are adequate. The risk is properly managed. Okay, case closed. On to the next what if. But, it doesn't always end that way. What happens when the analysis finds a real gap, a place where the safety net is weak? Well, that's when the plan turns into action. Right. So when the team asks, what if, and they realize the safeguards they have are not good enough to handle that risk, the analysis doesn't just end there. That's what triggers the next phase, a formal recommendation for an improvement. And this isn't just some suggestion box either. This process has real teeth. A hazard gets identified, a specific recommendation is created, An owner is assigned, meaning someone is now personally responsible for it, and that task is tracked all the way until it's verifiably complete. No loose ends. Here is a perfect real-world example from the report. The team asked, what if a vehicle, like a truck, hits one of the main pressure vessels? The consequence wasn't minor, it was catastrophic, and the existing protections just weren't enough. So what was the recommendation? Something simple, direct, and incredibly effective. Build a physical barrier. Install a security fence, and that's how a what-if question leads to actual concrete and steel.
So when you start to zoom out from all these individual what-ifs and their action items, you begin to see how they all weave together to create something much, much bigger.
This whole process, this art of systematic worrying, it creates a powerful, invisible safety net. It's a net that protects the employees inside the plant, the community around it, and yeah, even the products that eventually end up in our own homes.
But a safety net like this can't just be set up once and forgotten about. It has to be checked, it has to be repaired, and it has to be recertified. And that brings us to one last crucial number: 5.
Every 5 years, by law, this entire process hazard analysis has to be done all over again. It has to be revalidated, the team gets back together, they look at old scenarios, they think about new equipment or changes, and that systematic worrying starts all over again. Because safety isn't a one-and-done project, it's a continuous cycle.
This whole plan is just a perfect example of a system working silently in the background to keep us all safe. And it really makes you think, doesn't it? What other invisible safety systems built on this exact same kind of methodical worrying are protecting you every single day?